In this lecture, we will be solving linear equations that require multiple steps to solve. The steps that we want to take when solving linear equations is first to distribute, eliminating any parentheses. Second, we want to multiply both sides by the least common denominator to eliminate fractions. We do this especially when we have more than one fraction. Third, combine like terms on each side of the equal sign separately. Fourth, move all variable terms to one side of the equation and all constant terms to the other side of the equation by applying the addition property of equality. Fifth, we want to eliminate the coefficient of the lone variable by applying the multiplication property of equality. Typically, we're dividing here. And then lastly, we can always check our solution. The first equation we're going to solve is 10 equals 2m minus 4m. The first two steps don't apply to this problem. We don't have any parentheses to eliminate or fractions to eliminate. So we move on to the third step of combining like terms on each side of the equal sign. We notice on the right side of our equation, we have like terms that can be combined. 2m minus 4m gives us negative 2m. Next, we want all of our variable terms to be on one side of the equation, all of our constant terms on the opposite side of the equation. We have that. We move on to step 5, eliminating the coefficient of the variable by dividing. To eliminate multiplication by negative 2, we divide both sides by negative 2. On the right, the negative 2's simplify, giving us 1m, and on the left, we get negative 5. Our solution is negative 5 equals m. In our next example, we do not have any parentheses to eliminate. We do have a fraction, but it's only one fraction, so I would not be inclined to multiply both sides by the LCD to eliminate. We'll talk in the next lecture about how to solve equations that have a lot of fractions in them. We do have like terms on the left side that can be combined. Negative 8 plus 6 is negative 2, equal to a divided by 5. We want all of our variable terms to be on one side of the equation, all of our constant terms to be on the opposite side. We have that. Now we want to get that variable term all by itself. To eliminate the division by 5, I'm going to do the opposite operation, and I'm going to multiply by 5. On the right, our 5's cancel out, leaving us with just a, and on the left side, we have negative 10. The solution to our equation is negative 10 is equal to a. In our next example, again, we do not have parentheses or fractions to eliminate. This time, we don't have like terms to combine on either side of the equation either. We move on to step 4, making sure that all of our variable terms are on one side of the equation and all of our constant terms on the opposite side. We notice that all of our variable terms are already collected on the left side. That means that our constant terms must be moved to the right-hand side. I need to eliminate a plus 2. I'm going to perform the opposite operation and subtract 2 from both sides. This leaves me with 5y is equal to 15. Next, we want to get that y all by itself. To eliminate the coefficient of 5, we're going to divide both sides by 5. This gives us a solution of y is equal to 3. In our next example, we do have parentheses to eliminate. We are going to distribute to eliminate those parentheses. 4 times 3x is 12x, and 4 times a negative 1 gives us minus 4. There are no fractions to eliminate. There are no like terms on either side of the equal sign to combine. Step 4, we want to move all of our variable terms to one side of the equation and all of our constant terms to the opposite side of the equation. Notice that all of our constant terms are already collected on the right side. That means that our variable terms must move to the left side. To move this positive 12x, I'm going to subtract 12x from both sides. The 12x's cancel on the right, leaving me with negative 4, and on the left, 13x minus 12x gives us 1x, or we can simply write x. The solution to our equation is x equals negative 4. In this example, we don't have parentheses to eliminate or fractions to eliminate. We do, however, have like terms on each side of the equal sign to combine. On the left side, I see that I have constant terms to combine, which is going to give me a negative 5y plus 45. And on the right-hand side, we have variable terms that can be combined, a minus 2y and a minus 4y. Combining those like terms, I get minus 6y minus 10. Next, we want to collect all of our variable terms on one side of the equation and all of our constant terms on the opposite side of the equation. For the first time, we notice that we have both variable terms and constant terms on both sides of the equation. Well, this means that we have options. We can choose whether we want to have our variable terms collected on the left side or the right side. It's your choice. I like to move the variable term that has the smallest coefficient. Negative 6 is a smaller number than negative 5, so I would recommend moving the minus 6y. Since it's a minus 6y, I'm going to add 6y to both sides. The reason I choose to move the term that has the smaller coefficient is that it's going to eliminate having a negative coefficient on the variable when I'm left over. This is the 6y's on the right, cancel out. On the left, negative 5y plus 6y leaves me with a positive 1y plus 45 equals negative 10. Now that all of my variable terms are collected on the left, I have no choice but to move my constant terms to the right side. To move this plus 45, I'm going to do the opposite operation, and I'm going to subtract 45 from both sides. 45's on the left cancel out, leaving me with just y, and on the right-hand side, negative 55. The solution to this equation is y equals negative 55. In our next example, we'll start by distributing to eliminate the parentheses we have. 6 times a is 6a. 6 times negative 5 is a minus 30 equals 4a plus 4. We don't have any like terms to combine, Now we want to get all of our variable terms on one side of the equation and all of our constant terms on the opposite side. Again, we have the situation where we have both variable and constant terms on both sides of the equation. So we can choose which side we want to move our variable terms to. Like in the previous example, I recommend moving the variable term with the smaller coefficient. So I'm going to move this 4a. It's a positive 4a, so I'm going to subtract 4a from both sides. A's cancel on the right side. On the left, I have 2a minus 30. That's equal to a positive 4. Now that all of my variable terms are collected on the left, I have no choice but to move my constant terms to the right. I'm going to add 30 to both sides. This gives me 2a is equal to 34. The last thing that we need to do is eliminate the coefficient of a. To eliminate the multiplication by 2, I'm going to divide both sides by 2. This gives me a solution of a is equal to 17. We're going to look at a couple application problems. We want to read the application problem and develop an equation to represent the situation and then solve it. LaTanya is planning to buy a new car. The down payment is $2,373. She has $1,947 saved. How much more does she need? I'm going to let my variable be the amount of money that LaTanya needs. Why did I choose that? Well, because that's what they're asking us to find. That's the unknown. So let's let x be equal to the amount of money LaTanya needs. The down payment is a total of $2,373. To get that down payment, she's going to have to combine the amount of money she already has with the amount of money that she needs. So the right side of this equation is going to be 1,947 plus x. Now we need to solve for x. We go through the same steps as we did before. Distribute if we have parentheses. Eliminate fractions. Combine like terms on each side of the equal sign. We don't have to do the first 3 steps for this equation, so we're on step number 4, which is getting all of our variable terms on one side, all of our constant terms on the opposite side. Since all of our variable terms are already collected on the right, that means that I must move my constant terms to the left. To eliminate a positive 1,947, I'm going to subtract 1,947 from both sides. This gives me 426 is equal to x, which means that LaTanya needs $426 for the down payment of her new car. In our next example, a patient must receive 350 cc's of a medication in 3 injections. He has received 2 injections at 110 cc's each. How much should the third injection be? Again, I want to start by defining what my unknown is. They're asking us to find how much the third injection should be, so that's going to be my variable. We're going to let x be equal to the amount of the third injection. He's supposed to receive a total of 350 cc's. This equals the first injection plus the second injection plus the third injection. So the first two were each 110. And the third injection, well, that's our unknown. That's our equation. Now we want to solve. There are no parentheses or fractions to eliminate. However, we do have like terms on the right-hand side to combine. This gives us 350 is equal to 220 plus x. Next, we want to get all of our variable terms on one side, all of our constant terms on the opposite side. Since all of our variable terms are collected on the right side, that means that our constant terms must move to the left side. To eliminate this positive 220, I'm going to subtract 220 from both sides. This gives me 130 is equal to x. Therefore, my solution is that the third injection is 130 cc's.